All right, so we've been establishing the algebraic system, right? But we haven't really looked at anything that's usable, worthwhile. So we're gonna continue building the system, and that's what we're gonna do until the break. And after the holidays, when we come back, we're gonna be putting it all together and then using it, and you're gonna see why and what you're doing these for. Okay, so keep that in mind. It's sometimes hard to really see why you're doing what you're doing when you're just learning the pieces of something, right? But bear with me, it'll all come together in the end. So today what we're going to do is we're going to talk a little bit about writing and evaluating algebraic expressions. A huge problem for most algebra students as they move forward is that they don't understand the vocabulary. And questions are asked using specific math terms, and you don't know what those math terms mean, so you don't really know how to work the problem or answer the question, right? So that's what we're going to be addressing today. We're going to be talking about some vocabulary and what it means, and many of them, though, we've used in this class because I always make you use the right words, yeah? So the first thing I want to remind you of is these are algebraic. And how do you know that something is algebraic? Because it has variables. Now, and because they're algebraic, they are no longer made up of just numbers, but they're built up of what are called terms, right? But we can still have numbers. They're just number terms now, right? Okay, good job. And the other word that I put up there is the word expression. Now, an expression is simply a collection of terms and operations. But the easiest way to decide that something is an expression is by looking at what it is not. It has no equal symbol. And if you call it an equal sign, I'm perfectly fine, although is it an equal sign? No. What's a sign? Positive or what? Negative. And that we've been taught that word, it's fine. It's really an equal symbol, but it's fine. Okay? Now, because if it had an equal symbol, it wouldn't be an expression, but a what? Equation. An equation, exactly. So just about anything that's not an equation is an expression. Okay? So it's just a collection of terms and operations. You can have addition, you can have subtraction, you can have multiplication, division, right? They can be algebraic terms, they can be number terms, they can be both. You can have one term written down, and that's an expression. Okay? It's anything that's written in algebra, as long as it doesn't have an equal symbol in it. Okay? So what we're going to do today is we're going to look at some words and build a vocabulary that will allow us to write our own algebraic expressions. And most of these, they're just simply the words for the operations in mathematics. Okay? And the lesson is in Education Perfect is pretty good and pretty fast and easy, simple, and besides it gives us some good examples. So I think I'm going to use it, but no, of course, I'm going to tell you which parts I need you to write down. Okay? So it doesn't follow that half-page format like I like, but that's okay. We'll get there. So you'll write your own notes. Mm-hmm.
Are we going to do Education Perfect for the last few minutes?
If we have some time left over, you bet. Okay? All right, so here we go. So what I want to do is, sorry about that, is we're just going to go to writing and evaluating algebraic expressions. So, we talked a little bit about what an expression means. An expression just means that you have some collection of terms. And so what we're going to do to write expressions is simply change the words into numbers and letters and operations. Okay? All right. So, for example, and then after that, we're going to use substitution to evaluate some expressions. Now, we need to talk about that phrase, evaluate, and I think on the next slide they actually define it. Okay? Maybe they don't. Maybe they do when they get started. Don't worry about it. We'll define it in a moment. All right? So, we're going to take some phrases and turn them into algebraic expressions. In order to do that, we need to know the language. The good news is that the language hasn't changed from arithmetic. It's exactly the same words. For example, if I say the word sum, what operation immediately should pop into your head? Addition. Right? So that's what we mean. And the first few slides are just going to go through those words. So the first useful word is sum. If the sum of two things, that means you're going to do what with them? Add them together. Right? So that's what we're saying. So if they give you an example here, the sum of h and 5 means simply add h and 5. Now notice that the h came first and then the 5, so that's the order you need to put them in when you're doing the sum. Now, when you add, does it really matter? No, addition is one of those that you could reverse if you wanted to, but get in the habit of writing things the way you see them. Okay? All right. Difference. What does difference mean to do? Be careful. Subtract, right. Yeah, it's a minus. So anytime you're doing difference, you take the first one and subtract the second one from it. Now, does it matter the order when you're subtracting?
Yes.
Absolutely matters, right? Okay, good. So here, look at the example. The difference of h and 5 means h minus 5. It's good? Okay. The next useful word is the word product. Product always means what operation? Multiply. You're going to see that quite a lot. It's very important that you understand multiplying. Okay? All right. You betcha. So the product of h and 5. Now look how they wrote it.
5h.
Right. Where's the multiplication symbol? You don't need one if you're multiplying a number times a what? A variable. Excellent. But notice the number always comes first, even though it was h times 5, that's really 5h, right? Okay, good job. And finally, the last one is quotient, which means what operation? Divide. And division is usually in algebra division is written as a what? Fraction. So occasionally you're going to see the phrase over. And they use it. I don't like it very much. I would say divided by. But if they say over, that means divided by. Yeah, that means put it in the fraction bar. In other words, you're dividing. Okay. All right. So another useful word you're going to see is the word all. If you see the word all, that means put things together. You want every bit of it. And usually that means put things in a bracket. You won't always see the brackets though, right? If I say all over, that means you put everything and then the fraction bar. And then you don't need the bracket because the fraction bar is separating them. And you're going to see examples of all of that. So look at this one. H plus 1, so H plus 1 literally, all multiplied by 3. So that means multiply that entire quantity by 3. So you put the 3 in front of a bracket. That means we're not just multiplying the h or the 1 by 3, but what? Or. Both of them, all of it. Good. Okay. Here's where they talk about the word over. That just means divided by. Okay. So here we go. Let's write an expression and we can check the words. So the difference of y and 3. Difference means what operation? Subtract. All over. All over what? 5. And so that means that entire difference over 5.
So all means like?
All means everything that came before that, right?
Okay.
So everything that came before that would go over. So this entire difference of y minus 3 goes over the 5. Okay?
Cool.
Good deal. It's not a groovy video, trust me. It's stupid. All right. Write an expression for the following mathematical statement. The product of 7 and p. What does product mean you're doing? Multiply. And if you multiply 7 and p, what do you get? 7p. Literally, you can't multiply them together, so you just stack them side by side. 7p. All divided by q. What does that mean? Fraction, the whole thing, fraction bar with a q in the bottom. Okay? All right, so let's look what that looks like. And there we go. 7p over q. Yeah?
Okay.
All right. So then you're going to have some homework doing that. The next piece we need to talk about is we need to talk about evaluating. And we haven't really talked too much about that word. I've mentioned it before, but you know what it means. We just haven't used that phrase for it. Okay?
Oh, look at the little puppy. It's evaluating the situation.
There you go.
That's
All right. Okay.
Smarter
All
than me.
right. So evaluating, guys, come on. This should go in your notes. Evaluating means substituting in values for the variables and then calculating the results. Okay? So, to evaluate, first, substitute. Second, simplify. Remember, simplify is that math word that means do all the math using the order of what? Operations. So to evaluate, you'll first substitute, which means put the number in place of the letter, which we did. That was our last lesson, right? And then you'll simplify it, which means do the math. So evaluate and substitute are about the same thing. Yeah? Same thing that we did last time. The only difference this time is that you're first going to write the algebraic expression that you're going to then evaluate. Okay? All right. Right? To evaluate means substitute and then simplify. So you'll see in their example, they say they're replacing the q with the 5, right? And then they'll do the math for it. You ready? Substitute, then simplify. Okay. All right, guys. Okay, guys. So there we are. So they're simply substituting the 5 in place of the q. All right. So that's substitution. Some expressions are going to have more than one variable in them in the same one. So in this case, the d occurs twice. Does that mean it's a different number in each place?
No.
Absolutely not. If it's the same letter, it gets the same number. Okay? Throughout the expression. It can't have two different values in the same expression. Okay? When you evaluate, you're not limited to substituting in one variable. In this case, we have p's. We have what? A q and a what? R. So in order to substitute and evaluate this one, I need a value for p, I need a value for q, and I need a value for r. You can't evaluate unless you have a value for every single variable in the expression. Okay? Now, make sure that you're substituting numbers. Remember I told you that you're never allowed to substitute a number without putting it in a what? Bracket. If you do, then you change the process, the operation. So look at this one. 8p plus 5 when p equals 5 is 8 times 5. They didn't use a bracket, they used a multiplication. I would prefer that you use a bracket. You can't, but notice what happens if you just put in, so it's 8 times 5, that's the correct way. But if I just put the 5 in place of the p, that turns that into 85, right? So that's not right. I would rather you use a bracket than the multiplication symbol.
Because what if there's like exponents?
Exactly, because you know that a bracket is usually more than just multiplication. Exactly. Okay, good job. All right, so make sure you put things in a bracket. Once you've done that, you simply use the order of operations, right? They're just showing you multiplication and division first, then addition or subtraction. Again, addition and subtraction, we just use the sign rules for, right? So they combine depending on the sign rules. So here we go. Here's one for us to work. So Given that x equals 3 and y equals 4, evaluate the following expression. Now we're going to do this one together. So that tells me that the first thing I need to do is x is equal to what number in this case?
3.
3. So everywhere there's an x, which in this case there's only one x in there, I'm going to replace it with what number?
3.
3. But I can't replace it without putting it in a what? Bracket. Okay? Now 12 is a 12. And then it also tells me that y is equal to what number?
4.
4. Now, do I need, since the y is all completely by itself, nothing else with it, do I have to have the bracket there?
No.
No, that's the only time when you're allowed to omit the bracket. You can just put the 4 in. Okay? Now I need to evaluate it, which means simplify it using the order of operations. So first I'm going to look for multiplication or division. Do I have multiplication or division? I have multiplication and what? Division. So which one? So I do them as I come to them from left to what? Right. So first I see the multiplication, 2 times 3. What's 2 times 3 going to make? 6. I'm not using the addition, so just bring it down. Then I get to some division. What's 12 divided by 4 going to make? 3. The multiplication and division is done, so all that's left is just to combine those. What's 6 plus 3 going to make?
9.
And that's your completed answer.
Wait, give me a second. I need to write all of that down.
Okay?
2.
All right, guys. So there you see, they replaced it. They didn't use brackets. They used the multiplication symbol. But I would prefer you use a bracket. But they did get the same answer. And finally, the last step of this homework assignment is where we're going to put them both together. We're going to be given the expression in words. We're going to translate it to an expression. And then we're going to evaluate it. Okay? So let's look at what that looks like. So first, we're going to write an expression for the following statement and then evaluate it where P equals 16 and Q equals 2. So first of all, it says the difference between P and Q. So what does difference mean to do? Subtract. And I'm taking P minus what? Q. Could I have done Q minus P? No. No, be careful. Not with subtraction. You must do it in the right order. Then it's got the comma. That tells you a new thought is starting, right? The next word you see is all. What does all mean? That entire P minus Q. Yeah? Not just one of them, but both of them. Divided by what?
7.
So how do I write divided by 7? Big fraction bar with a 7 in the bottom. Right? So we write division as a fraction. But make sure your fraction bar goes completely under the entire expression P minus Q because of the word all. Okay? Now, it gives me the values that I need. What number am I going to put in place of P? 16. And since the P is all by itself, do I need a bracket? No. Minus, what am I going to put in place of the Q? 2. And since the Q is by itself, I don't need a bracket there either. All divided by 7. And now I'll do the math. Remember, when you're dealing with fractions, you always simplify the numerator, simplify the denominator, and do the division when? Last. It's the very last thing you do. So 16 minus 2 is what? 14. Divided by 7 gives us?
2. Perfect.
How easy is life right now? Life is good.
No, it's not.
Yeah, it's all. Okay? All right? Okay, so next, see, they've plugged in the numbers and evaluated it and got their 2. So here, we're going to do this one together, and I'm going to call on someone. So go! You have 1 minute to complete this. It's more than one. It's more than enough time. Just, if you stop complaining, you won't be missing your time.
I need an eraser. Oh, thank you.
You're very welcome.
C equals 4 and D equals 2? No.
Yes.
I need an eraser. I accidentally wrote it wrong.
I want you to write the expression, then put the numbers in, and then do the work.
I was about to do something wrong. Wait, what?
See?
Minus?
26 seconds. That's all you needed.
Do you have to write it out Like all of it? Like, like...
I want to see the expression, then I want you to put the numbers in.
Oh, I gotta write it down.
Yes, please.
No clue. Does it have to have a fraction like this one?
Yes.
Okay, then I didn't do it right.
Because you have
Because you're quotient.
quotient.
Yeah, but why does it say minus?
Minus the quotient. So product of 9 and 6 minus...
Ah!
Yeah. So it's very much like that one we did.
I wrote it down right. It's in here at the first one.
What?
36.
I don't even
Okay.
think it's close to being right, but that's okay.
36.
You ready? Oh, where's my...
Is it
Hey.
32?
Oh, wait.
That's not what I got. I probably still wrong. Don't think it's minus
Oh, there it
4,
is.
32.
Thought I lost my app.
Oh, I just did one bit wrong. I see where I went wrong. Yeah.
Okay.
That's true.
Here we go, guys. Olivia. Hi, Olivia. So let's do, you and I are going to do the first part of it. The first part says that we're looking for the product of C and 9. What does product mean? What operation is that? Product means to do what?
I did it on the wrong side of the
No, product means times, multiply, right? Good job, okay? So Charlotte, so it says the product of C and 9, so we know product means multiply. What do I get when I take C and multiply it times a 9?
You get
That. So what is C times 9?
C9.
Now,
9C.
9C. Come on, guys. You answer the questions when it's your turn. Okay? All right, Caroline. Then it says minus the quotient. So what am I going to put after the 9C?
Fraction bar.
Oh, be careful.
Oh, minus. And then
Minus means
fraction bar.
subtract, right? The quotient, what does quotient mean you're doing?
Divide.
Dividing. That's good, Emily. And what am I dividing?
8 and D.
So I'm going to, how am I going to write that? Which one goes on top?
8
8.
divided by D.
There you go. Okay, well, we're getting there. Yep. Okay, good. Bua. Next it says we're going to start evaluating. So here I have my expression. And in place of C, I'm going to put what number? 4. And do I need a bracket when I replace it with the 4? Yes, this time I do because the C is not by itself. So it's 9 bracket 4. Minus 8 doesn't change. Kath, next I need to put a number in place of D. What number? Do I need a bracket? Do I need a bracket around the D? No. Around the 2? No, because you don't need a bracket because the D is all by itself. Yeah? That's the only time when you don't need a bracket. Good. Chania, now I'm going to start doing the math. What do I need to look for first? Which part am I going to do first? 9 times 4. The 9 times 4. Good job. What's 9 times 4 going to give me? 36. Excellent. Okay. Amy? All right. And I'm going to bring down the minus. Then I'm going to do the 8 divided by 2, which is what?
6.
8 divided by 2.
8. Oh, 4.
4. There you go. Okay. And then finally, Sonari, I'm going to do that subtraction. What's 36 minus 4 going to make? 32. There's a lot of pressure. Sonari's like, wait, changing gears. All right. Keep up with me, folks, and then you'll know what you're doing, where you are. Okay, so here we go. So your completed answer, 32.
Correct.
Excellent. Good job. Okay.
I know what.
Wait, Mr. Sal, why did you put down 9C instead of C9?
Because
you said that
the number always, with multiplication, if you multiply a number times a letter, so any number times any letter, no matter what order they start out with, so 8x times 9 is 9x. You always put the number first.
It looks better.
Yeah.
I
Okay?
thought that you said that you had to think like if it was like
Not multiplication. The order doesn't matter when you multiply. Okay?
then why do you have to number first?
Because in algebraic term, we always write the number first.